Welcome to springlib.
So for this problem, we start off with this formula, s equals 6sh minus 3 halves s squared cotangent theta plus, I'll move this a little bit, plus 3s squared root 3 over 2 times cosecant theta. Then if we differentiate with respect to theta, what we end up getting is ds d theta equals 3 halves s squared times cosecant squared theta, because we cotangent, the derivative of cotangent is cosecant squared theta, minus 3s squared root 3 over 2. And then remember, the cosecant derivative is going to give us cosecant theta cotangent theta. So that's going to be our first answer for part A. Then we have part B. And for part B, we want to minimize the surface area over volume. So surface area is already given, and volume will be independent of theta. So that's because volume of a prism is 1/3 height times the area of the base. So height and area of the base are independent of theta. So what we need is theta for which surface area is minimum. So given what we already have, which is this equation up here, we've already differentiated with respect to theta, and we got this, and then we set that equal to 0. So if we take this right here and set it equal to 0, we end up getting 1 over root 3 equals cosine theta. So theta is going to equal approximately 55 degrees. So now we've determined the theta for which we can minimize our volume, or minimize our surface area. So then we substitute this in for the given expression. So now we have s of 55 degrees, and then plug that in. So what we end up getting as a result is going to be, once theta is in, we'll end up getting the minimum surface area to be 6sh plus 3 over root 2 s squared. So this will be our final answer for a minimal surface area based on the theta that we just found.